Good morning, sir.
Good morning.
Morning. Good morning சொல்றதுக்கே பிள்ளைகளுக்கு பஞ்சு ஆகிருக்கேன் காலம் மேல எழும்பினோம். அந்த அளவுக்கு சோம்பறி போல. Right. Yesterday I gave you a example in the nested design. We are not going to talk about the calculation, but I will give you the summary of the ANOVA table. All right, you can cross-check your answers with the summary table. So this is the ANOVA table, summary of the ANOVA table, right? Hello, can you all hear me?
Yes, sir.
Yeah, I can. Give me a second, something wrong with the system. How about the slide? Can you all see the slide?
No, sir.
No. Give me a second.
Oh, okay.
Yeah. Right. So this is the summary of the ANOVA table. Actually, you don't need to do this part. This part is not necessary. We will see that because this is a computer output. This is the output of a software, so that it gives everything. So I have simply pasted that. So you don't need to do this because you cannot do that because it is giving the exact probability. But you can go up to this table. You can fill this table, no problem. Right. Looking the table, you see here these are the source of variance, area, then site. Sites are within the area, so that is why I have put area. You have factor A, then you have sites, which is B, within the area, then you have error and the total. So this is actually two-factor situation, area and the site, right? So we can find out the degrees of freedom as we define using the formula. The first ANOVA, which I have given you. You can calculate the sums of square. You can calculate the mean square according to the formula. Right, when you calculate the F value, right, this is for factor A or area. I'm calculating the F value for area. So can you remember yesterday I gave the formula for the factor A? What is the calculation value or calculated value of F? That is the mean square due to A divided by mean square due to B within A. Right? Can you recall? So according to that, the value here is equal, what is the mean square of area? That is 2.25 divided by, what is the mean square of PA? Because here the denominator, or we use the denominator for area as the mean square of side B. So that is equal 14.25. Usually this is replaced by the error term. But can you remember here we said we are using the side B mean square as the error term. because it is random. Later we will see, because it is random, right? Because it is a random factor, right? Therefore, area can be random, so that area can be divided by as the error term of the site. So that is equal, right? That is equal, you are getting a value 0.158. Cross check and see whether you are getting the same value.
Okay, sir.
Okay, you are getting the same value, fine. Right? So that is why you are getting the F value. Now, my F value is this one. This one we will have to test it. Now, we want to see what is my hypothesis. Now, I will keep that value. I will erase that value. So my calculated value is, I am testing first for area, right? My calculated value is 0.158. What is my table value? Forget about these two. What is my table value? What is the degrees of freedom? Numerator degrees of freedom. What is the numerator degrees of freedom? 2. What is the denominator degrees of freedom? 9. Look at in the F value, what are those values? And tell me, because I didn't open my, yes?
2 and 9.
2 point? Vishnavi?
Sorry, sir. 4.26.
4.26. I didn't get it, your value.
Yes, sir. 4.26.
Right. So this is the numerator degrees of freedom. This is the denominator degrees of freedom. Okay. This is for, what is the alpha value? Look at the T value for, F value for alpha 0.05, not for other alpha. Right. Now, what can you say about this distribution? So this is F distribution. Here my critical value is 4.26. This is the rejecting region. This is non-rejecting region. Our rejection rule is, if calculated value is greater than the table value, then we reject. This is our rejecting rule. So according to this results, our calculated value is very, very low, which is 0.158, which is less than our table value, which is 4.26. Therefore, do not reject H naught. Do not reject H naught. So what is our H naught? What is our H naught? We are testing for the area. What is our H naught? Can you remember? Yesterday I have shown you.
Alpha equals 0.
Yes. Alpha I is equal 0. The effect of area is 0. Right? Alternative, at least one area effect is different from rest. Right? So that is my null and the alternative hypothesis. Here we are talking about area effect. I'm testing only the first area. I will see testing among the sites. Right. So we do not reject our null hypothesis. What is my conclusion? Anyone? There is no difference In what? What did we measure? Kind of measurements. I couldn't remember. If I go back, I will lose this. There's no difference in particular attribute among the area. So there's no difference in particular attribute among these areas. So no difference between the areas, right? So that is how we conclude it. Just a second, I will look at it. What is? Three areas, 4 sites. Within each area, replication of site. This is not given. The units are not given. So that is the problem, right? Units are not given, so it doesn't matter. So we could say the area is not significantly, there's no significant difference between the areas. So all the areas are showing more or less similar results. Now we can test for site. So sites, actually, it is indicated by the factor B, but it is indicated by factor B. However, it is nested within A. So we are going to look at the sites. Here, as I said yesterday, no interaction that we will have to see. We cannot say about the interaction because all the combinations are not there now. So we cannot talk about interaction. So now earlier we have looked upon site A, factor A. Now we are looking at factor B. So in that case, my calculated value is actually mean square of site B or factor B within A divided by mean square of error. That is how the calculation goes. So that the values are 14.25 divided by 4.5, which is equal 3.167. 3.167. Right. Look at my table value. What is my table value? Anyone? So numerator degrees of freedom is 9. Denominator degrees of freedom is 24. Again, the alpha is same, 0.05. Now, tell me what is the table value? Somebody? Somebody, what is the table value?
.3.
Pardon?
2.3.
2.3. Is that correct? 2.3 by others? Yeah?
2.30, sir.
Okay, fine. 2.30. Anybody else? A different answer? Right. So now you see, according to our rule, our calculated value, if calculated value is greater than the table value, we reject our null hypothesis. But here our calculated value is 3.167, where the table value is 2.3. So definitely calculated value is higher than the table value. If you look at in the distribution, this is my border where 2.3. This is the rejecting region. This is the non-rejecting region, right? So that if you look at your calculated value, which is 3.167, it is falling there, 3.167 in rejecting region. So we could say we can reject our null hypothesis. So what is my conclusion? What is my conclusion? Anyone? But here, the sites are nested within area. Huh? So what is the conclusion? How we can write? There's a difference between sites. There's a significant difference between sites within area. We have to tell that within the area, there is a significant difference between sites. So we have compared the sites within each area. We didn't compare all the sites together. So that the conclusion is there is a significant difference between sites within the area. Right? Clear? That is how it goes. Right. So we have seen already the example 2-factor situation. If it is 3-factor, it is a bit complicated. As I said, we'll have to have one more component here. Sorry, one more component there. Right? If you have 3 factors. Yesterday, I have given the ANOVA table for the 3-factor situation. So this is a 2-factor situation. Factor A and factor B. Right. Any questions on this? Any questions on this?